And so today we just wanted to provide an opportunity for you all to ask your questions, ultimately around the fact that, with the understanding that every resident in Evansville needs safe, clean, reliable water and also affordable. It's something that is very important that we continue to hear concerns raised around, and there's been a tremendous amount of work been done prior to our administration coming in about what do we do, whether that's build a new treatment plant or go an alternative route. And what you're going to hear about today in a little bit more detail is an alternative route. We've pivoted to what we believe is going to be a more cost-effective strategy and plan to provide safe, reliable, affordable water supply and system for something that ultimately, hopefully, will protect our ratepayers and minimize future rate increases that we are currently under federal mandate to address. So at this time, I will introduce our director of Evansville Water and Sewer Utility, Kelson, who's going to just kind of provide some brief comments as well as answer any of the questions that you have specifically about this next move.
Thank you, Mayor. Tomorrow we'll be taking a project plan to our board. We'll be seeking the board's approval for a contract with an engineering firm to design a groundwater treatment plant and a well field to serve the city. Historically, Evansville has always used river water, and the cost of treating river water has gone up over time as we've started looking at completely renovating our water supply system. The original idea was to replace the entire plant, which proved to be too costly. So we looked at renovating portions of the old plant. Our old plant actually has two plants. There's a north plant and a south plant. The north plant is much older, and that was the one that really needs to be replaced. We would renovate the south plant and then build a new north plant, was the plan we were exploring. As we were going through that, we started looking into the possibility of pumping groundwater from the alluvial aquifer that lies along the river here. The reason for this is that groundwater is a lot cheaper to produce than surface water. Groundwater plants are smaller and take less infrastructure. But more importantly, the whole water industry these days is faced with a new series of contaminants called PFAS. PFAS stands for per and polyfluoroalkyl substances. That's hard to say. But basically, it's a bunch of chemicals that are organic chemicals with fluorine replacing hydrogens in lots of places. So these chemicals have proven to be suspected carcinogens, in some cases confirmed carcinogens, and we're now facing regulatory limits on 2 of those species. Our measurements of those concentrations from the river water are not in violation of the standards, which is great news, but high enough that in the future, if the limits come down, or if there's a major spill upstream that comes downstream, that we could get into a situation where it would be much more costly. So when we look at building a surface water plant that might cost $250 million, we might have to spend another $100 million on capital costs to build treatment into that system, which would require another rate case. The other thing is that in order to pay for that $250 million project that we were looking at, we had to suspend a bunch of improvements to our distribution system and water main replacements. So we suspended those projects, and as we started looking at groundwater, we believe that the cost of the groundwater plant will be small enough that we can restore those projects, which would be great for us in the future. Again, we don't want to have to do another rate case in order to pay for those distribution system improvements. So we think we got a really good plan. We estimate that construction of this, we've already started a $50 million renovation of that south plant that can be renovated. We estimate that the cost of adding the groundwater blending option will save about $100 million compared to building another surface water plant. So in short, it's a long way of being short, but in short, we think this puts us in a place where we're going to save our ratepayers a lot of money over time. It will delay future rate increases, and it will allow us to pursue the system improvements that we really need. So I'm happy to answer any questions.
Go ahead.
Are residents already seeing rate increases with the state of how you guys are currently getting water to the city?
Great question. We did a rate case several years ago that had 5 year-by-year steps in the increases. The last step will be executed next spring of those. So, and after that, at this point, we don't have a rate case in mind. We believe we have the revenue that we're going to need to do the projects we're talking about.
What are some examples, this might be a stupid question, but what are some examples of groundwater, surface water, kind of to help people understand where that water is coming from when you say you're going to mix the way that you're grabbing it? What does that look like?
Also a great question. So groundwater is water that lies between the sand grains in a sandy aquifer system, or here we've got really good sand and gravel aquifers. So if you've been to the beach, you dig a hole and water flows in, that's groundwater. It's flowing through the sand into your hole. And one of the good things about groundwater is there's natural filtration of all the solids. So the water you get has very low contents of solids. Whereas if you look at the river, it can be pretty cloudy a lot of the time. The first step in treating surface water is to get all those solids out. Well, if you treat groundwater, you don't need to do that part. That's already done. But the other chemical treatment that you have to do is less costly as well. So fewer chemicals, less waste that you have to dispose of, and so forth. So it's cheaper. But basically, what we do is we would treat groundwater, get it into the proper condition for drinking water. The surface water plant that we were renovating would also be treating to drinking water standards. And the idea is that we don't want to change our distribution system at this time. What we would do is blend those 2 water streams after they were treated and then send them on to the customers.
Should they notice any difference in taste or anything like that, or should it be the same?
We're going to do everything we can to make that not noticeable. The one thing that people who've been around the area for a while know is that groundwater in some of our neighboring communities tends to have a lot more hardness than the water that we get from the river. We're aware of that, and we're planning to soften the water at the groundwater plant to get it to basically the same hardness as what we get from the river. So there are other chemistry things that can happen when you blend water streams that we'll be studying and making sure that it won't make the water more corrosive or any of those other kinds of things. So we'll be paying really close attention to all those effects.
I know Mayor Terry mentioned a little bit about this, but what was something that kind of sparked this idea? Did you see the need in people's utility rates, or was it something else?
Well, this is going to sound weird, but I'm a groundwater scientist by training, and this conversation started when Sean Wright, who's our director of planning, and I were talking with each other about the big project, the big surface water plant. And he had worked with groundwater in the past as well. And we had looked at the studies. There were studies done about groundwater that before the plan for the surface water plant. The conclusion was that there wasn't enough groundwater available to supply the whole city in the vicinity of the existing plant. What we realized was we don't have to replace all of it. We only have to replace half of it. So the idea then became, okay, let's build a surface water plant and see if we can supplement it with groundwater. So it's not saying anybody did anything wrong. It's just we looked at it from a slightly different angle, blending the water after it was treated.
How is water out of the ground cheaper to filter versus surface water?
When it comes from the ground, it's already been through a sand filter. So what we do at the treatment plant is we add a chemical, alum, that causes the solids in the water to clump together and then settle out. Then after that, we put it through a sand filter. So if we take it from a well, it's already been through a sand filter, and those suspended solids were never there because the water infiltrated right into that sandy aquifer.
Could you go into a little bit more detail about what exactly PFAS, is that how to pronounce it?
Yes.
Could you go into more detail as to exactly what those
Well, there are lots of them. When we did our testing, we tested at 2 locations here on the plaza, and we built a test well over at 5 East Riverside Drive. There are 39 different species of those that they test for right now. Here at the plaza, we only got a hit for one of them, and it was a really low concentration. The other place we looked, we didn't get any. These chemicals have been made for, you use them all the time. So they're in Teflon pots and pans. That's one of the species they use to make Teflon. If you buy a food package that's in a little cardboard box, that if you ever look inside there's a plastic lining and nothing sticks to it, well, that's because it has PFAS in it. It has sort of a Teflon-y kind of material, but it's used for things like fire foams, flame-resistant clothing, lots of different things that, raincoats. It makes water bead up on surfaces. So that's really, it's used for all those kinds of things. So it shows up in lots of consumer products, lots of industrial products, and it shows up in the Ohio River.
What causes it to show up in the river?
Well, spills upstream is one reason. The other thing we find is that residual PFAS can show up in wastewater. So you may have an industrial facility or someplace that had formerly had the PFAS-containing fire foam, where that water is running off and ending up in the sewers. So it can end up, we do test our sewers. The state has a program, EPA has a program for testing sewer water for PFAS. And it's an ongoing issue to get rid of that. But it's going to take a lot of time to get rid of it. It's been around for about 80 years or so, and they find it everywhere.
So this isn't a concern that Evansville is unique in. I'm sure every long-lasting city in America and across the world has similar issues to this.
Well, everyone in America does, yes, because these chemicals have been pretty ubiquitous in American society, certainly in Canada as well. But these chemicals have been around for a while, and it wasn't really discovered how dangerous they were until 10 or 15 years ago. It's one of those things that's been a growing concern in the water industry, and EPA only started regulating it in 2019, I think. The standard was actually set just a couple of years ago.
Have you received any pushback about this new plan, or do you expect it to go over pretty smoothly?
I'm hopeful that it'll go over smoothly. We haven't heard a lot of complaints. I think we introduced this at Rotary about a year and a half ago, right? We gave a talk at Rotary about this as a possibility, and we started doing the field testing. And we've been working with our board. They've been very supportive of us investigating this. And it's only now that we're to the point where we're really ready to, we've got all our ducks in a row for financing the plant. We've got everything in place to move ahead. So this is the time to do it. So we'll begin the design. It'll take 6 to 9 months probably to finish the design. And then we would go to bid and start construction.
Now, I know the board is voting tomorrow on this issue. How soon after the vote will you guys start the process of construction and bidding and stuff like that?
Well, it's an engineering design project at this point. It should take 9 months or less, I hope, but it could take a year to finish the design. Once the design is done, one part of the design project is to develop the bid package, and we would put it out for bid shortly after the design was completed.
Now, for the current water plant that we have here in Evansville, I know it's at least over 100 years old. What are the renovation plans? Are those included in that bidding for the project?
Oh, that's a great question. What we did was we've been working on parallel tracks between the surface water plant and the groundwater plant since it started looking promising for groundwater. What we did was identify the things that were renovations to the south plant that would be done in either case, regardless of what the final outcome of the groundwater study was. That's about $50 million, and we have secured financing for that, and we're actually going to be releasing those project bid packages this Friday, is that right? This week? In the next week or so, we'll be releasing the bid packages for improvements at the south plant. Most of those improvements at this point are all at the intake station. So there's a lot of motors and drives and pumps and things that are going to need renovations there, process controls, things like that. We're also going to be making some improvements to the rest of the plant, but those projects will be beginning very shortly. Once those once we've received the bids, we'll move on to contracting on those and get rolling. So we will be working continuously through this period as we're doing the design for the groundwater plant.
I want
Thank
to
you.
just close out, just publicly thank Vic for, number one, his technical expertise, but then also just his leadership. It's been, what, 21 months or so?
Something like that.
Something like, very close, that, again, that we've moved in this direction, and really it's attributed to his leadership and the team at EWSU. And so I'm really excited about the direction that we're headed. I believe this is a win for our community, and looking forward to how things progress.